Okay, thank you very much, Richard, for the short introduction. And by the way, you pronounced my name quite good, actually. My name is Richard Savenije. I'm Dutch, actually. So I'm quite honored to be invited to do a speech here about you. But at the same time, I was also wondering why. I was a little bit, well, why did you invite me? Because first of all, I am not a programmer. I'm not a computer programmer. I'm not working in the IT sector. And I just recently started 1 year experience with APL. But when I looked at the audience, and thanks for showing me the results of the poll, at least half of the people joining now have barely knowledge or just started programming APL, and even a quarter of them have never touched APL. So what I really would like to do is tell something about my experience. Why am I programming in APL? What does it give to me as a non-programmer? And was it a steep learning curve, or what did it bring to me? Well, first of all, as I explained to you, I'm not a programmer. Actually, I'm a project director. I'm working in a consulting and engineering company on infrastructure projects. So I do a lot of things in my work, but not programming. However, I'm solving problems all the day, complex problems, and I always have to look at problems, take a step back, analyzing them, and looking at the basics, how to solve things. And more or less, you're doing the same with programming in APL, and that's what I would like to explain to you now. But maybe my audience is going to be the less experienced users, but maybe the way I start to think about problems could also address the more experienced people. Let's start with how I did get in touch with APL. And to be honest, that was already 30 years ago. It was during my very first job at IBM. And I know that some people joining now are working or have been working with IBM. I started as a computer programmer. I got lessons about the C programming language, but the job lasted only for 8 months. I discovered that programming wasn't my ambition to do the rest of my life. So I started to go into the consultancy part. But 30 years ago, while working on IBM, doing debugging, I was debugging all day long, I noticed a magazine on my table, or a journal, or a small book on my table, which was covered with all kinds of glyphs. And that made me really curious. What are those glyphs? What is it? And I asked my colleagues, and I said, well, what kind of book is it? Where is it being used for? And they said to me, well, Richard, that's a programming language. I knew about the C language. I could tell the C language, but it didn't look like a programming language. So we started making a little bit jokes about it. My colleague said, well, APL, it's a dead language, just like reading Chinese, and nobody uses it anymore. But still, it intrigued me. I found it really interesting. And well, I still call them glyphs. They make me think, well, what is it more about? What should it be? Is it useful? So I picked up the magazine and asked my colleagues, what are you going to do with it? We're going to throw it away. We got lots of them, but it's old. We're not using it anymore, so we're throwing it away. So do you mind if I take it with me? No problem. Just take it with you, Richard. Be my guest. So I put it in my bag, and well, finally I did put it in my bookshelf. And to be honest, it stayed there for 28 years. 1 year ago, I was attracted a little bit, so that's 28 years later, a little bit attracted about programming again. I had some experience on the C language. I had some problems, some mathematical problems I would like to solve. And instead of going back to the C language, I thought, well, in 30 years, things must have been changed. Surely not everybody is still programming in C. Well, I did some Googling and I found, well, C is still a major programming language, but there are other languages. And I got my vision on more matrix-oriented language like BQN, like J, but also APL. And I don't know exactly why I choose APL, but I think I was attracted again by the glyphs. And instead of having a direct opinion, saying it's old and not being used again, I thought, well, maybe I should just look at it a little bit further and try to learn it a little bit and look if it's useful, if I can do something with it. And actually, I was caught by it almost directly. Yes, there are strange glyphs. It's very basic. But after reading some introductions, and actually on the internet, there are some really good introductions, also online studies you can do, a lot of exercises. And I can tell you, after already 5 minutes, I could make my first program. You only need, I think, like Adam already showed, just a few functions and you can make your own program. And maybe most of you know the C language. If you want to make the Hello World program, most of it is garbage around it, and only a very small part really is doing what you would like to do. Maybe it's not a good example, but if you go back to APL, it does only what you want to do, and there is no garbage, no additional things around it. So it's basic, but it's really, really tempting to try, and it brings you back to the basic solution of your basic problem. So I started learning a few of those glyphs. I won't call them glyphs anymore, that's functions and operands. And I really did have fun in it. If you can already make your first program after 5 minutes by remembering just a few functions, it is really rewarding, really, really rewarding. So the next step, what I did is I did do a competition. At the end of each year, there is a so-called Advent of Code, and you are presented with a few problems, which are more or less a story. It's getting more complicated every time. But there are problems presented, and they start very easy. And to my surprise, I managed to solve 5 or 6 of these problems already. And at the time, maybe I had been programming or looking at APL for 2 or 3 weeks. So that again was really, really rewarding. And it's not only the advent of code which made me so enthusiastic about programming APL, but also the community. One of the very nice places I should recommend to you to visit is APL Orchard. A lot of people, also people joining right now, are on the APL Orchard and giving advice, and you can ask all the questions and whatever. And I also realized you never can ask a stupid question. The only thing you can do is not ask it. People are always helping you, and that's made me even more and more enthusiastic. And after that point, it went really, really fast. I learned more functions, more operands. I tried more programs, I did some challenges, and it went very, very fast there. And personally, I really like to be challenged, and I also like to be a little bit different and out of the box. But at the same time, you need to invest. Sometimes it seems like a steep learning curve, all those strange symbols, but once you get them in your fingers and you know where to find them on the keyboard, thanks Adam, you see that it's not so complicated at all. And that makes you focus on the problem itself instead of programming. So you're looking at the problem and not directly you are programming. And even after the first try, as I just explained, it's extremely rewarding. And to make it even a little bit more clear, I have a small example, and I'm going to share a presentation with you. I assume, Rich, is it visible for everyone? Yes. Okay.
We can see that.
Okay. I told you already about the APL Orchard, and every week we discuss problem. We call it the APL Quest, and those are simple problems which are from the yearly APL contest. I will discuss that later on. Those are quite simple problems, and it's really fun to try to solve them. And this is one of the problems I would like to highlight because it emphasizes and it makes it very clear for me why APL is such a logical and nice language to look at your problem. What you can see here in this graph, and you have to have a little bit of imagination, are skyscrapers. You can see 7 skyscrapers in a row, and the first one has a height of 5, the second 5, one of the height of 2, one of 10, 3, 15, and 10. And imagine yourself standing on the left side and looking at the skyscrapers. How many skyscrapers can you see? Well, in this case, you can see the most left skyscraper. I'm not sure if I can use my mouse pointer, Rich, is it?
You can see it, but also, is this PowerPoint? Well, let's not add to the complicated. I was going to say, if you control click, you get a red thing, but we can see.
Oh, yes. Okay, thanks. So in this case, if you're standing on the left side and you're being asked how many skyscrapers can I see, you can see the one on the first position, you can see the one on the 4th position, and you can see the one on the 6th position. Well, the question in this one was, write a program which calculates how many skyscrapers you can see. Instead of directly starting to program, which is very tempting, at least for me, if you know a C language, you just can start programming and writing something down. You first have to think about, what is my solution? What system I'm going to use? How I'm going to analyze this? Well, I'm going to explain you what my solution is, and afterwards I show you the program itself. What I did is, well, I imagined myself standing on the left side, and if you're standing on the left side, you can always see the most left skyscraper. You can see the second skyscraper. That's only in the case when the second skyscraper is higher, or at least as high or higher as the first 2. The third skyscraper you can only see if it's the highest among the first 3, etc. The 4th skyscraper, in this case, with a height of 10, you can only see if it's the tallest along the first 4 skyscrapers. So first, what you do is scan along the skyscrapers and look for each one if it is the tallest in the first series. Now, there's one small problem in the case of the 2 of the height of 5. Yes, it is the largest in the set of the first 2, but we only want to have 1, so you want to have the unique one. So if you follow this algorithm, and every time you look if it's the largest, the tallest in the series, you only have to add up the amount of skyscrapers which are left over. And that is exactly, I hope I made it clear. Sorry, English is not my native language, but I hope I made it clear. And if you look at the program which I made, that does exactly what I just explained. So it's not a large textual programming. It's just a few symbols which exactly tells you what I just told. The omega is the argument. So those are the skyscrapers with the different heights, which I just showed you. Adam and Rich already explained what the other symbols are. And this is just the first part. It's just scanning for each series which the highest skyscrapers is. Then I only want unique ones, filtering out the double 5 in this example, and then just count them. How many are there? And this is the solution I made up for this problem. And there are different solutions, the more efficient, maybe faster, but for me this translates exactly how I would analyze this problem in real life and not by programming. So actually, I'm not programming, I'm solving a problem. And APL helps me to make it basic and simple, and well, just like it stands here. Instead of only this solution, I can also raise the bar. And there are many ways to raise the bar in APL, or many different complex function operators. But another way you could raise the bar for yourself is using tacit programming. And I understood a lot of people are afraid of tacit programming. I'm not going to explain completely what it is, but the basic for me, in my words, tacit programming is leaving out the garbage and unnecessary things. So you only have left what the basic functionality of the program is. In this case, we leave out mentioning the arguments, because the function always has arguments. And that's what I will show you in the next slide. So I made this one Tacit, and it's even more compact. And again, you can do this in a different way, but it's even more clear how I found my solution. Here again, just scanning around which are the highest, the tallest buildings, make sure that you only have the unique ones. And after that, I'll skip the symbol, but it means after that or on top of that, we are going to count them. That's it. So 5 characters, and that's the whole solution of the problem. It's not about getting it as dense or small or compact as possible, but it shows you the essence of your solution. So that's why I think also Tacit program is a really nice way to do it. It's not a must. You shouldn't always use Tacit program only if it makes it more clear and more visible for others how you made your solution. So that's my opinion about it. I can make it even more clear, I think, with a different example. And those are my last lines of code, actually. So I hope everybody still can follow it. This is a very small program. What does it do? First of all, I'm starting on the left side. I'm summing up all the arguments. Then I'm dividing it by the amount of arguments. So the sum divided by the amount of arguments, which is the average. So this line of code, and I can also write it differently. We can make it different, of course, but this just only calculates the average. Well, it's not difficult to see, it's not complex, but now let's make this one Tacit. Above the line is the original one, and underneath there's the Tacit one. And for me, this is even more clear than the one above. What are we doing here? We're looking at the total sum, and we divide this by the number of elements. So that's the average. So just in 4 symbols, just in 4 characters, you can directly see what it does, calculating the average. And once again, using Tacit programming is not a holy grail, but in this case, if you compare the up one with the low one, I think the low one is much more clear what it does. Well, there's a lot more to discuss about Tacit programming. I'm not going to do that. I just wanted to show you, don't be afraid. It's not as complicated as you think. And actually, it makes sometimes it's much more easy to understand and to see what you're trying to solve and what is your solution. Okay, I quit the presentation again and going back to my normal presentation. Okay, so I gave you an example why I really like programming APL. But what does it bring for me? I started my presentation that I'm not a programmer, I'm not in IT business, I'm just a project director, dealing with problems, of course. But for me, APL programming gave me another way of looking at problems. It really forces me to go back to the basic. The APL language has only a handful of functions and operands. So once you have a problem, you first have to think at it, how am I going to solve it? You don't start directly with programming, first you think. First thinking, then programming. And APL forces you to do so. I don't have really much experience with other programming language. I happen to know the C language, but I found it very easy in C language just to start programming and afterwards thinking, well, is this a good solution or not? And after a while, you get lost in the amount of code you put in your screen. APL, for me at least, but it's probably also going to be with other languages, but APL really forced me to really start thinking about the problem and then start solving it and start programming. Another thing APL does for me is if a problem is too complicated, try to split it up in small problems, solve them and put them together again. So decomposition. And decomposition is a typical thing which helps solving more complex problems. Put them out and make a small piece of them, solve them one by one, and then put them together. And APL just gives no escape. As I said, there's only a limited amount of functions and operands, etc. So it gives no escape. It forces you first to think and then start doing things. And another thing which is really nice, I just showed you the Tacit example. Once you've finished your solution, take a step back, look at it again. Is it the best solution? Or maybe I should rethink it. And if your whole solution is visible just in a few lines of code or in one line or just a few characters, you can comprehend it much more easy. And it really makes you thinking, can I do it different? Can I use a different approach, etc. So take a step back, rethink your problem, and try to look for a different solution. And actually, that's exactly the same which I'm doing with my job. Always taking a step back, being forced sometimes to do so, and try to look for a different solution, which is maybe even better. And but it's my personal opinion, I always like to be challenged and always like to raise the bar all the time. And I think APL has a lot of opportunities to raise the bar. I mentioned tacit programming, but there are also much more complicated operators you can look in through, which will help you in the longer term. So raising the bar, decomposition, going back to the basic, APL almost forces you to do so. And it really puts your thoughts in a different way. As I said, 30 years ago, I had a magazine, people making jokes about the language. It's almost like Chinese. And I should learn that in a very steep learning curve. But let me express you an analogy. Maybe it's just like learning a different language. If you are trying to speak a language, for example, French or German or Dutch, if you are starting to learn a language and you're just walking around them, you don't understand anything. Maybe it sounds tempting or romantic, and then I'm not talking about the Dutch language. I don't think it's a romantic language, but let's say the French language. You don't understand anything at the beginning. But after learning just a few words, maybe you can order a croissant or order a beer at a pub. And with just a few words, you make your first contact with the people and they understand you. And well, a bad thing in France, when you start talking just a few words in French, they think you know everything, and they start talking fast and loud and long, and so you don't understand anything again. But you are rewarded. You get your croissant, you get your beer, but people get enthusiastic and they take in with you, and you're starting to be a little bit a part of their culture. So you start talking back, but they start talking back also, and the bar is being raised, as I said, because maybe you don't understand anything anymore. And after a while, and maybe after a few months, you are even able to order your meal in the restaurants. Maybe you can do small conversations, you can ask directions to other people, and you're really starting to get a glimpse of the culture, the behavior, the way of thinking. And that's the analogy I would like to make with APL. Yes, it might be looking complicated, but once you try it, I think already very, very, very fast at the beginning, you will see you can make your own solutions already, and you're challenged all the time. And the bar is being raised, yes. And for this example, after a while, you start making friends. Maybe even you can make jokes, and making jokes in not your native language is maybe the most difficult thing to do. So you're always one step behind, but it's not a competition. And you're starting being part of the community, and you start to understand them, and you really start what's behind them. Just instead of just looking at their language, you really start what you're doing, why you're doing it, and how you can make a conversation. So what did it give to me as a beginner? And I think I'm still a beginner after 1 year of programming. it's raising the bar. I really like raising the bar, being challenged all the time. And at the same time, in every step, I'm being rewarded. I'm being rewarded by the small solution I just presented you for looking for the high buildings, but also being forced to going back to basic. Start thinking about your solution, and after you have done that, then start programming. And there's no escape, as already said you. So there's no disguising by trying out and combining pre-cooked partial solutions. You really have to go back to basic and think how you're going to solve your problem and then start programming. And that is, at least by my opinion, just like real life and just what my job asked me to do so. Then finally, what is next for me after 1 year of programming? Well, actually, there are a lot of things for me still to learn and to get challenged all the time. And once again, I would like to recommend you to go to APL Orchard. Every week we discuss a small problem which comes out of the yearly APL programming context, which is running also at the moment. It's that contest. So I really would advise you, if you are starting with APL, or if you are just curious, join our conversation. Maybe Adam can tell something about it. I really should recommend that. And keep learning. I will keep learning all the time. There are a lot of things to do about Tacit programming, code challenges. I'm trying, but also looking at more complex operators. And above all, being rewarded all the time is really, really satisfying. If you manage to solve something and the solution is just a few characters, again, that's not the goal, but the solution is sometimes such a simple thing which makes you really, really happy. And for the very first starters, my advice will be don't be scared. Maybe it sounds complex to you, maybe you're afraid of the cliffs, but don't be scared. And I promise you, if you just look 10 minutes at a few first functions, you can make your own program. And it's really, really, really easy. But dare to challenge yourself. Don't stop there. Continue, so you really discover what is behind the language. Raise the bar for yourself and ask questions. Ask questions. There are a lot of people who are wanting to help you. As I said before, I think the worst thing you can do is don't ask anything. Just ask questions. There are no stupid questions. And don't be afraid to make mistakes. And I promise you, you will be really, really rewarded. And that is what I would like to address to you. This is my speech, Richard.
Awesome. Thanks very much, Richard. I'll come back up. Yeah, I'll get nice feedback in the chat, and also there's one question I can, if that's all right, if I can ask you here for the last minute. Jose asks, Richard, thank you for your inspiring story and sharing your views. Do you also get to use APL at work sometimes, for example, to analyze data? Have you ever used APL for work-related tasks?
Sometimes I did, yes, sometimes, but mostly I'm just talking to people and telling them what to do and not to do.
Right, yeah.
As a director. But yes, sometimes I do. If I have some data and want it ordered fast, yes, I do sometimes use APL, yes.